Good afternoon, everyone. This panel will be talking about how to electrify everything, the electrification of everything. I'm your moderator for this afternoon. I'm Craig Douglas, one of the founding partners of World Fund, a 350 million climate tech venture fund. And why I'm here is I've been investing and advising governments for the last 15 years in how to decarbonize the electricity system. So I have three excellent additional panel members with me here today. I'll let them introduce themselves rather than introduce them myself. So maybe Julia, you can kick off and introduce yourself.
Of course. So thanks so much, Craig. Thank you for inviting me. My name is Julia Renaud. I'm Senior Director at Breakthrough Energy, and you saw one of my colleagues on the panel before, Eric Dusseux. I'm working for Breakthrough Energy, which was founded by Bill Gates in 2015, all with the mission to go from 51 gigatons of CO2 down to zero in the next 26 years. And we're focused on this, specifically looking at it from the 3Ds. How do we support discovery? How do we support development? And how do we support that deployment? And we think of this in terms of technology, of course, and the impact. So 0.5 gigaton of CO2 at scale is what we're looking for. But then we also look at it from the perspective of capital. So we've got different sources of capital, grant funding, equity for the capitalization of companies, and then blended finance for projects. And last but not least, of course, technology capital is one thing, but thinking about the policy environment, how do we make sure that we have the policies to scale, and then the partnership. So it's a big organization, but a great one to be with.
Nida, maybe.
Thank you so much. Thank you for the invitation to be here today. And I'm very excited to meet all of you and the panelists. So my name is Lina Bertlin-Tjernberg. I'm a professor in power grid technology at KTH in Stockholm, Sweden. I have seen a lot of my colleagues actually here. Very nice. And so I have actually spent years being excited about power grids. And it's the high voltage infrastructure I work with. But the last years, I've also been working at my university trying to stimulate to collaboration between scientists in the energy area in general. And I will be very happy to discuss with you today. Thank you.
And finally, Michael.
Thanks, Greg. So I'm nice to be here, by the way. Mike Finelli. I'm the Chief Technology and Innovation Officer of a company called Science Co. We're a brand new company, 3-month-old, but we have a 160-year history. We're a spin-off of the Solvay company. Some of you may know Solvay. We are the specialty materials, so we're a chemical company. We make many types of polymers, and we do a lot in the megatrends around electrification. We have platforms around lithium-ion batteries, and everything we do is materials and chemistry. So it's materials around lithium-ion batteries. We do materials around green hydrogen. We make the key ionomers that split hydrogen and oxygen in the electrolyzers. We also have a platform around thermoplastic composites for lightweighting. If you can make vehicles, planes, trains, automobiles lighter, you need less energy to push them. And the most brand new platform we have is called biotechnology and bioresources, where we're using microorganisms and bringing that technology from the pharmaceutical industry, bringing it into industrial chemistry. So it's a very exciting place to be. I've been there 30 years. I've never had a boring day. Well, 30 years with the previous company, 3 months with the new company. Nice to be here.
Thanks very much for that. So just to set some context for the panel, we're going to take generation as a given. So we're not going to talk about huge generation projects. We're going to talk about, assume we've got an abundance of energy. How do we get that energy to where it's needed, and how do we actually get those sectors to get onto the electricity system? So, maybe to start with, where are we today, and what more, give us a scale of what the opportunity is or what the requirements are. So maybe Lina, you can kick us off here.
Thank you so much. So I think where I would like to start is where we are targeting, and I'm wearing my sustainability pen today. And we normally try to think, where are we going? And I think starting now here in Paris, in Europe, it's very strong, clear to us where we are targets. So our targets are very clear. And that we need a lot of generation of electricity to go there. And what we see is this huge need of all kinds of generation to go there. So that is really where we are. And then we have to set up how we can reach there. So that is, I think, one of the key things now, that we have to do a lot of things to reaching that. And that, I guess, is what we will come back to a lot of the discussion today. But it's a lot of regulation in there, a lot of learnings, a lot of need for innovations and so on that we will come back to. But the target, I think, is very important, that we know where we are heading. Thank you.
I mean, maybe Julia, you can give, I mean, maybe just set a little bit of context in terms of where we are today and what the opportunity is in certain sectors, right? So the electricity system is only so much today in Europe, and just to decarbonize one or two sectors might involve us doubling or tripling or quadrupling the energy requirements today. So Julia, I think you have some good examples here.
Sure. So, I mean, the way that we're looking at how we decarbonize our economies is sort of a prioritization list in terms of thinking about how we can electrify as much as possible. So that means electrifying heat, that means electrifying end uses like mobility, but it's also then thinking about if you can't electrify, how can you bring up the green molecules? And electricity is also going to be very much required, and Michael can speak more to that. And so thinking about then how do you electrify things, or how do you provide the green molecules to what we call hard-to-abate sectors, thinking about the aviation sector or thinking about the manufacturing sector like steel, which is an area I've been working on. And also, if you can't address both that electrification and if you can't address the green molecules, is thinking about then carbon management. How do you think about storing the excess CO2 that we have? And then, of course, thinking about resources across, and how do you recycle and reuse because of the non-infinity of our natural resources. Now, we've been working on a number of things, not just in terms of electrification needs, but also how do you actually move that electricity and how do you store it? Because, as I often say, is that it takes two to tango. So if you want more renewables, you're going to need more baseload, other electricity, low-carbon sources, but equally around storage. In terms of electrification, we've done quite a lot of work on the industrial sector, which today, as they want to heat their processes, think about food, think about paper and pulp, those types of sectors, and thinking how we can electrify that heat. And we try to distinguish between what is commercially available today, so think about technologies that can provide that heat service for 400 degrees. I always like to think about sort of what does that mean tangibly, is sort of if you think about how you make your chips or how you make your whiskey, you know, thinking about how you can electrify that. It's clear that today there's a lot of technologies that are available for electrifying that heat, but still there's a challenge because it's a new process. It's a new way sort of electrifying, and so thinking about what are some of the challenges related to that. But we're basically seeing that 90% of the heat in that sort of lower temperature can already be electrified. Now, another piece where we're also working on is more around the end uses, and I'll give you two case examples. If you want to decarbonize the steel sector, particularly looking at Europe where I'm based, and using green hydrogen, you know, we're talking about 500 terawatt hours of electricity. And if you want to decarbonize also how you make the fuels for the use of the aviation sector, knowing that about 2/3, depending on the scenarios, are going to be needed from sustainable aviation fuels, we're talking about 500 terawatt hours. To put those two just examples in practice, what does that mean? That's the combined doubling of what Germany today produces in terms of electricity. So as you can see sort of the scale of the challenge, which really means that we need to rise to that challenge of that scale.
Thanks very much for that. And Michael, I think you've got some great examples from the areas that you focus on here.
So Julia, you know, she mentioned some really important points. She talked about hard-to-abate industries, right? We want to electrify our society, but electricity is not going to be the solution for everything. There are many technologies that are going to have to come together for this to work. And you know, one of those technologies Julia mentioned was hydrogen. Now, there's many ways to make hydrogen, but if you want truly emission-free hydrogen, okay, so many people call this green hydrogen, and many people don't like the colors, but it is what it is. You need electrolysis, and there's a couple of different ways to do electrolysis, but you need green energy to feed that electrolyzer. And if you do that, you know, you start with water, you split the water molecule into hydrogen and oxygen using a membrane, and then you can recombine that later with another membrane to generate electricity, and you have water as a byproduct. But you need this green energy, and some reports that I've read, we need about 1,000 times more solar and wind energy than we have today for this green hydrogen economy to happen. And I don't think we will reach carbon neutrality as a planet if we don't have a strong hydrogen economy. So it's not electricity, but you need electricity, and it's part of the equation. And that's something that, personally I'm really passionate about, because I see a tremendous potential with green hydrogen moving forward.
Oh, I like that as a comment. Like, it doesn't have to be, electricity doesn't have to be the primary utilization, but it is the founding energy source to allow you to decarbonize entire sectors.
There's many, as you said, Julia, hard to abate industries, right? I mean, people think mobility, right? So you think about, automobiles. Unlikely we're going to see a widespread hydrogen economy around passenger vehicles, but you will see it around trucks. You'll see it around buses, long-haul trains. You're going to see it in aviation. Industry like steel, as Julia mentioned, is going to need hydrogen to decarbonize. So there's many places that will need this, and we're going to need this green energy to fuel these electrolyzers.
Yes.
No, and if I can just add, I mean, I think as you're saying, certainly the green hydrogen is going to be at the source of being able to decarbonize some sectors like steel, but they're also at the beginning of their journey in terms of electrification. If you think of some of the technologies like Boston Metals, which is the electrolysis of steel making, I mean, again, I think the general consensus is you're going to need more electricity in order to be able to decarbonize rather than less, and tripling is the number, which also comes then with the tripling of grids in order in that infrastructure to be able to transport those electrons.
Yeah, and we'll focus on that in a bit. Like, if you assume we have an abundance of energy, how do you go from that to actually utilizing it, right? So we all know the infrastructure requirements here are huge, particularly on the grid reinforcement side. But are there any areas that are often overlooked in terms of key, but are not actually being addressed with the infrastructure side of things?
I could take a stab at that. So, when you think of electrification, I mean, one of the key drivers of the electrification movement is electric vehicles. And being a materials guy coming from that segment, I'm going to talk about materials. To bring electric vehicles to the world in mass, right? And it's growing significantly right now, but when you talk about the transformation that has to happen between ICE engines and electric vehicles, it's just massive, absolutely massive. And most people think about the metals, they think about the lithium. My God, we don't have enough lithium, so we need more refining, we need more mines, et cetera. It goes so far, your question, what's often overlooked? There are dozens and dozens of small volume materials needed to make lithium-ion batteries possible. One of them is our material, it's called PVDF. This is a binder. It's only used in 1% to 2% of a battery, of the weight of a battery, but it's critical to the functioning of a modern lithium-ion battery. It helps exchange range anxiety. It helps the battery perform safer. It is a material that you would not have today's performance without, and you can't make the current batteries without it. We just announced last year the investment to build an $850 million plant in the United States. That's enough to just do about 5 million EVs. And long term, I mean, there's about 80 million to 100 million cars that need to be converted. So think of the investment that has to be made. We're a pretty large company. We're about 8 billion euro. I don't know how many of those $850 billion investments we could make. Now imagine there's a lot of these ingredients that are being produced by small and medium companies. Where does that financing come from? How do we make that? How do you de-risk these investments? I think this is something, we focus on the big stuff, but some of these small volume products absolutely also have to be built. We have to build this entire supply chain.
Thanks, Mike.
Maybe I can point to three sort of things that I think are underestimated. One is just the awareness from governments or from regulators on what is in the innovation pipeline. We're just doing now a study around what are the innovative grid technologies that can help sort of channel more electrons through high voltage grids or better channel sort of the inertia that's in the grid. And so I think being able to have awareness of what are some of the technologies in the pipeline is really one of the key things that we've put out our mission to sort of build on, which is raising that awareness. The second is perhaps to sort of the big problem that we see related to the grids, but also with regards to other technologies, is the regulation and the permitting. It takes 12 years to have a high voltage grid and on average to be built, much less time if you want to connect an EV charger and an infrastructure. But even in France, if you want to be able to connect to the grid, if you're a large energy intensive user, it's going to take up to 5 years. So 5 years really is a challenge when it comes to making actual final investment decisions. So those are two major roadblocks. And the third is probably one that we'll talk more about, but is this financing question around de-risking and how do we make sure that we actually have the types of financing that are going to help go from a prototype to a pilot to a first of a kind in so many areas and including in the storage sector.
One thing that we maybe have not discussed so much before is the need of a lot of competence and people working in this field. And so that is something I think we need to add. But another just technical point that I just would like to bring in is that we talk now a lot about the technologies and a lot of the also challenges with the knowledge that we need from different actors. But in reality, the topic here is on electricity. And all of you sitting up here are probably using two things now. One is your digital communication, but the other is electricity. Because if you look at the lights now, it looks quite stable. And the reason this looks stable, that is because the power system is working. And that is, if you talk about things we don't normally mention, that is because of it, because it works. So we have to work on different levels all the time. And we talk about these different technologies here. But on the higher level, it's actually a monopoly. We normally have a TSO. In my country, we have a TSO, and normally in larger countries, maybe we have more, and a lot of TSOs. And we need to communicate in between this. And one of the things I normally say about electricity is that it's wonderful, we like it, a lot of generation, but we should not use electricity if we can do something else. For example, if we want to heat something, it's very good to use warm water, waste warmer, etc. So it's normally a combination, and that's why I said that we are normally expecting to have electricity like we do with internet, etc. And then we are adding on these technologies. But it's important to understand we cannot just add them on if we don't have the infrastructure and grid. And that is something that I think it's not always visible on the plate. Thank you.
Yeah, absolutely. And I think the people aspect is an interesting one. I think Germany is missing 100,000 electricians to install heat pumps. Like, those people aren't trained. Like, just to get one part, just heat pumps installed in Germany, you need an extra 100,000 people to be able to do it.
Maybe I can add, last night I gave a speech in the Swedish parliament because we are giving regular seminars from the science part in order to discuss or give like fact, independent information for the parliament members. So we were talking about this topic yesterday, and then I had scientists from the whole country of Sweden. And up north in Sweden, they just told us that they need 100,000 people now. So it is a lot of growth in the industry in this, and hydrogen is one of the market that's really huge. So we need a lot more people at the end, and minerals.
We were discussing this in terms of the coordination of people as well. Like, there's the infrastructure, the finance, we'll get to that, but like coordinating different groups to make sure that the left hand actually knows what the right hand is doing. Like, I think we're both involved a lot at the European Commission, and like one of the working groups that I'm part of, like we discussed, like the other working group that you're part of has no idea that the other party even exists. Both in theory doing the same thing, right? Actively promoting new business and financing models for the energy system, right? It's not always the easiest to get everything involved and everyone understanding on the same page.
One thing that we also, I think, clearly need to articulate is how to create the business case, right? Because all of this is this transformation. If I think about energy storage, again, that we're going to need to store the energy and make our system smarter, we're going to need to have more investments in the grid side, really thinking about how to create the business case. We know, for example, at the European level, we're starting to see more of a business case for more of related to the grid, particularly, and not just promoting CapEx investments, but thinking about what we call the TOTEX, which is something I learned about, the total cost of ownership, so that you basically incentivize more of these efficiencies into the grid. But similarly, if you're thinking about how do you create the business case for storage? You know, in Italy, for example, they had, a consultation process where they're trying to auction future storage for the energy system because they're trying to have more renewables. But the reality was, in their consultation, they were pushing for two types of very mature technologies, lithium-ion batteries and pumped hydro. the reality is that there's much more types of innovations out there, but if you're excluding them from a type of capacity market where there's actually a business case for them to come in, again, I come back to not just this question of business case, of course, the question of collaboration, but also how do you have that collaboration between the startups, the scale-ups, the investors who are investing in these technologies, and those that are ultimately going to set the rules of the game.
Yep.
So one perspective I like to add here is that when we look at the expenditures, the cost, things have really changed during the last years. And one of the concepts I like to bring in is the circular economic, where we can see that some of these technologies would have a second lifetime, for example. We will use the batteries from the cars as storage, etc. So it is much more complex to do the economic evaluation. And for certain, we need to do it in a longer time frame. And the models we used to have is not so valid anymore. So I think that is a really exciting area we are starting.
So if we move on to the financing side of things for a minute here, so the sheer scale required to increase electrification and decarbonization, like at the moment in Europe, a few tens of billions, maybe 100 billion or so a year. In Europe, we need to get to about 1 trillion a year. Globally, it's about 6 to 8 trillion a year. So what do you see as kind of the biggest bottlenecks in being able to get the companies to scale to be able to utilize and finance that to get there? And maybe, Michael, you stick here. You gave a really nice example earlier on your plant.
Yeah.
Like what did you need to be able to make that investment?
So, when you're looking at massive investments, billion-dollar investments, you need to have a level of certainty to be willing. Well, first of all, you need that certainty to convince your board to say yes, right? So, good luck if you don't have that certainty. And what we need is government regulations that are stable, that aren't changing all the time. If in the absence of that, you have to find another way to de-risk your plant. What we did in this particular case was we did apply and we were successful. So we did have government support from the United States Department of Energy. We received a $178 million grant. And this was absolutely critical in the decision of where we were going to put this plant. We have options. We could have built in China. We could have built in Europe. We decided to build in the US because they gave us $178 million. I think this is a critical part. This is a role that government can play. The IRA and the IIJA in the United States is very powerful. It's driving a lot of investment. I'm waiting to see Europe come up with something similar. I mean, there is quite a bit of money available in Europe for research and development, but pure industrial investment, the investment we're talking about, it's not really there yet. And this is something I think Europe's got to find a way to step up, or otherwise investments will keep moving into other countries. The other thing that I think is really important is that we're not, companies are not going to be able to do this all by themselves. You talked about trillions of euro that's going to be needed. So you need to find partnerships. And I like to look for partnerships where 1 + 1 = 3. And we found a great partner to build this plant, a company called Orbia. This product, it comes from a critical mineral called fluorspar. They have the largest mines of fluorspar in Mexico. So we're building an entire North America supply chain from the mineral all the way to the final product. So they come to the table with capital, but also the plus extra value coming from the upstream raw materials that give us security of supply. So when you bring all that together, strong partnerships, government support, and then you have to move downstream with your customers to get commitments from them to have guaranteed offtakes. You put this together and you could make it happen. Very difficult to do all of this on your own and take all of that risk on your shoulders.
Yeah, absolutely. And Julia, maybe because you've been involved in a lot of new financing mechanisms, maybe you could share the difficulty in getting companies to scale. What do we need to get companies to that point?
Thanks, Craig. So I would separate it out between sort of the company's journey and then the project's journey, because I do think that that's sort of separating out. When you're a company and you're sort of raising your Series A, a lot of what we're seeing is the dearth then of growth capital in Europe and the UK. Less sure about the US, but thinking about how do you have more growth capital in that space, and what then can be the role of public funding in trying to perhaps have a first loss so that you have more of these infrastructure funds and others that can come into the space where they're going to be able to help the companies grow and then set up growth funds. Then when it comes to the project financing side, certainly here, I think just as a good practice, making sure that a company has been able to finance its prototype, then it finances its pilot stage. But where we're seeing the biggest challenges is more when it comes also to the demonstration and what I call to the first of a kind asset class, where you're thinking about sort of, if you think of an energy storage project or you're taking an electrolyzer company that's building up, here you have the challenges with regards to, these are infrastructure projects, manufacturing to build the electrolyzer factory or manufacturing to build what is then going to be used as a storage. But they're infrastructure projects, but with a venture capital risk. And so I think you mentioned the area of guarantees, making sure that there are more guarantees. We're starting to see this in Europe after the wind package, where there was counter guarantees for banks. I think there's a movement towards making sure that there's actually counter guarantees for banks that are working more into the emerging climate technology space, and that's certainly an area where Europe should grow. But then comes to the point of blended finance. In order to be able to de-risk these technologies, it's not so much that all of them will be de-risked, but it's about properly sizing what is the type of risk. Is it an offtake risk? Is it a technology risk? Is it a construction risk? And then finding who is ready to take on that risk. To the good news of what we've been doing, at least in Europe, we at Breakthrough has set up a particular type of program called Catalyst, which raised over $1 billion from corporates like ArcelorMittal, but also from foundations like BlackRock Foundation. And what we're doing in Europe is particularly addressing that first of a kind in demonstration by being able to provide blended finance in the form either of equity and in the form of grants. And the matching then that we have with the European Commission and the European Investment Bank is at the portfolio level, if we put in equity, there's the venture debt or quasi-equity from the EIB, and if we put in grant for the first of a kind large scale, then there's a matching of that grant for the European Commission to cover what we call the green premium. So point is, it's this is honestly the Mount of an Everest when it comes to the actual capital needs, but this is particularly how we need to structure this first of a kind, the de-risking, so that it then is able to become an nth of a kind and project finance ready.
Yeah, I think that's an interesting point in terms of the other types of financing mechanisms available. You can do a lot with very little as a government. So a first loss facility, a technical guarantee, a export guarantee, the likelihood of that guarantee ever actually being called is tiny. So if you want to guarantee, like, you're never going to spend more than $1 billion doing it, you can probably leverage that to the tune of 10, 20, 30 billion. That's going to then leverage 100, 200 on the back of that with private finance. So there are mechanisms by doing it, but they don't necessarily exist today, and we're working on them.
The right hand needs to speak to the left hand, obviously, because more awareness around this is pretty important.
Yeah, absolutely. And maybe Lina, you have some knowledge of how the grid, different business models on the grid on flexibility, like how do you actually get things from one side to the other?
Yeah, I mean, one of the very exciting changes we have seen during the last year is that we are doing a different portfolio of the electricity generation, and we have a lot of new technologies in order to actually shift the generation in use of the storage. And we also have the previously type of customers that are now producing electricity. So this is a kind of very, giving a more complex system, but it's also have a lot of more features to do it optimal, to use resources. Just an example, we just finished up a pilot study sponsored by Vinnova in Sweden, and we were studying industry facility in Hofors, Ovako, and they are changing in the production process using an electrolyzer to reduce the emissions, and then they will have more hydrogen than needed in the process. So we have studied the benefits of using that for stabilizing the grid or to use for heavy trucks, for example. So here there are new business models and there are new features in order to balance this. We see other type of industries that can make a decision on shifting their production because of the cost, etc. And we also see industries that start to own generation. So, and that is the bad part, maybe, because we have seen that tendency too, that a huge industry own electricity and then they can earn so much on selling electricity. So maybe they are not even running their industry. So I think what we see is a lot more flexibility, a lot more choices, where the flexibility is one of the key issues. That is very exciting. And it's also one solution we talked about before, the long-term long time needed for building the infrastructure. And actually the flexibility here can reduce the need of doing that and speed it up. So it's a very, very important key. Thank you.
Yeah, and it's an interesting point. Like, how can we maximize? We talked earlier about we're going to utilize multiple times what we're utilizing today in terms of power, right? So we have a grid that exists today. If we want to try and upgrade that and utilize it the way it is today, the infrastructure requirements there are just astronomically high. So how can, what technologies can we utilize today and potentially in the near future that can maximize the existing capacity of the grid? Like, how do we maximize, get as much as we possibly can out of the assets we already have in the ground today?
Well, I guess it's not one solution to that, but what we see now is that it's a shift of market design. Because, I mean, if I say this from my country, is that we have these different areas, price areas, and now we're investigating to change those. And this is opposed to the regulation, because we are regulated in that aspect. But if we need a market design, and then based on that, and different political regulations will impact. For example, for a couple of years, we were promoting to use solar and wind for flexibility. Our TSO in Sweden started a special market from wind and solar. And we could see that a lot of households, a lot of buildings were bidding solar because they saw it was a business case for them to invest in batteries and solar. But now it's shifting a little bit, so now they are stopped, not so many people are buying this anymore. So it is also long-term knowledge, what will be kept, that will help for the investors. So that is also key in this issue, because if you don't know if it will change in a couple of years, it's difficult for you to invest in it.
I mean, two areas that I think we're looking into. One of them is around long-duration energy storage. So how do you store the energy, and how do you create a market then that values that storage of energy in the form either of heat or being able to retransform it in electricity? We've got, deciding two companies that are in the long-duration energy storage space, or there are so many more in the portfolio, but one of them is Form Energy that can store electricity up to 100 hours with an iron air flow battery. And so thinking here, we're talking about 3 days. This is when the grid actually shuts down because there might be a fire. And so thinking about what is the business case for that? I think there's a first of a kind, there's sort of those types of challenges. But to the point that you're making, Nina, is making sure that there's actually a market that supports that. There's another company called Malta that's trying to develop projects across the globe, but especially in Spain. Spain is now starting to think about, how do I create that type of market of flexibility in order for that to happen? I think there's a more immediate case for more, I spoke about electrification of heat, where you can then store that electricity and then use it for heat purposes, for food and other, the chips lays, as I mentioned. Here there's a challenge not only of creating that flexibility in terms of market, I think there's also a challenge related to the grids. Sometimes there's double taxation when it comes to the grid connection, so thinking about smart regulation, how much you need to actually revise the regulation. But equally, I come back to a point where you actually need more partnerships. I mean, to the industrial customer that's going to use that, and then thinking about the utility that's also going to be part of that. And what we're seeing in some of the portfolio companies, or also other companies that we're working on in this particular space of electrifying heat and being able to store it, is partnerships, for example, between Rondo, which is one of our portfolio companies, and Electricité de Portugal, EDP. Thinking about another company, Magaldi, that now has a partnership with Enel. It's thinking about, again, how do you get these into the market? How do you make sure that there's the right regulatory environment, that there's a market? But then what type of partnerships do you need, which, Michael, I think you've been mentioning around how do you work with then an ecosystem that can actually replicate and scale, and who's going to be the delivery for making that scale and replication happen?
Hey, Michael, as a...
I'd say maybe a comment at the end here. So going back to your question, I mean, how do we get the most out of the current grid that we have, right? Use less, right? I mean, use less energy. In our personal lives, but also when we look at our sustainability plans, our company's made a commitment by 2040 to be carbon neutral. It's not just about switching to alternative energies that are carbon, lower carbon or neutral. It's about using less of the energy that we have. So we have about 50 projects going on across the group right now. Some of them are about using less energy. Right? I mean, and in the products that we produce, we're also trying to find ways to bring products to the market that help our customers use less energy. I talked at the beginning about our composites business. This is all about lightweighting. If we could make a plane lighter, if we could make a car lighter or a bus or a train lighter, it takes less energy to move that vehicle. I think that's also something we have to continue to do, is to find ways to use less energy. And the combination of everything we just talked about and using less, I think, will help us get there.
It's an interesting point in terms of using less power. The other side of it is our grid is set up today for handling the maximum load at a specific time, right? Actually, if you could utilize the maximum grid capacity at its, at that rate for the entire day, you could double, triple the amount of power that you're physically putting through the lines. And whether that's using it from a residential setting, as you say, the flexibility, moving it to when you need it, or when it's cheap, or when you know you can actually get it out, like that's when that allows us to put so much more through the system than is currently possible today.
I mean, what you're mentioning now, we normally call dynamic riding. So that is a total different way of operating the grids than we have done before. So it's a very good example where we can use the knowledge we have from the digitalization. But there are some good examples on that. In Norway, for example, they did it for quite many years. And it's also quite, another way to do it is actually just to increase the voltage level. But then you need also to think about the, yeah, and I mean, it sounds quite maybe silly, but it's obviously this is very high voltage level, so it's not just to increase it, you also need to redesign it. You normally need to make the poles higher, and you need to include more power electronics, and to need to do a lot of calculations. But it's definitely faster to do it than to build something else. So these kind of dynamic models, and I can also mention, because we talked about how much you can push in. And recently in Sweden, it was a study made by the DSOs, because it is a great challenge now when they want to connect a lot of points to get a lot of capacity out. And what the system we had before was that someone asked, and then you say, okay, you need this power in 5 years from now, in 10 years from now, and then you're just pushing it on like a queue. And as anyone designing things, you take a little bit more higher than you need. So eventually you say, no, we don't have it, it's full. So the idea here is to do this one dynamic too, that you maybe can go back and say and revise it, that you say, I need this capacity in 5 years from now or 10 years from now, and then you can revisit it and say, maybe you can adopt it a little bit. And if you do this more dynamic type of planning, you can you can make more agreements on how you can use the grid. So that is another kind of flexibility we see it's coming.
And I just wanted to re-emphasize what you were saying, Michael. I mean, it's energy efficiency first, energy conservation first, and a lot of what I did in the past was actually working in China and India around energy efficiency programs for industrials. And the basic step is first start to have an energy audit. Then once you sort of know what you're talking about, then you can measure, and then you can monitor, and then you can be smarter about it. So come back 100% to that being the basic sort of first starting point.
Well, I'll take the counter position here for a second, because I think it's fun. But also I think, like, when you use the electricity, in often cases, is more important than how much you use. Like, if you're using it at a time when there's a huge amount of excess capacity on the grid, I'm happy for it to be half as efficient, right?
I'd say it's both, though.
Yeah, absolutely.
Smart, but then you also need to use less of it from the start.
Okay, so in order to make sure there's plenty of time for some questions from the audience, of which we have several, kind of one final question from my side. If you could ask for one thing that would increase the electrification, what would it be?
I can start. The one thing I would wish for are long-term agreements, long-term plans, because that's what we need in order to take good decisions and plan. Thank you.
I would say consistent and effective government regulations that don't change when administrations change, because it adds uncertainty. You can't one day plan on there being, EV credits to drive EV demand, and then the next administration comes in and they disappear. This doesn't work, because you don't build assets, you don't install assets for 5 years, 4 years, whatever the administration's there for. You build it for 20 years. So that level of certainty is really important when we're talking about the size of investments that need to happen here.
And I'd build on that, of course, on the regulatory side, is being innovative in the way that we regulate. I mean, the sandboxes we haven't talked about, but just being smart around testing and other opportunities there are. Second is around innovative finance. I definitely think we need to be more innovative to address this first of a kind. And then being more innovative as well in the way that we collaborate, both with the public and private sector, but equally between companies, and really sort of not having that risk-taking attitude in terms of this is a new technology, or I don't know what it's going to do is in terms of impact, or it's too risky for my first plant, but really having more of these, more small companies working with bigger companies in terms of being able to deliver not just that one project, but then replicate.
And because I'm the person moderating here, I can choose two, right? That's basically a combination of both. I mean, I think that's, I'll get the questions in a second. For me, this is a combination of both. Like, the only way you get long-term financing and stable financing is if you have certainty of regulation and you have long-term certainty. Like anything in the energy grid, you know, these are investments that need to last for decades and often take longer. So I have a few questions from the audience. So maybe an interesting one, well, for several people there. You know, how does the electrical grid rollout limit the electrification of energy-intensive industry? So that's an interesting one, because there's I think there's a bit of an argument happening at the moment in the Nordics of you know, which plants are going to get priority on the grid. Maybe.
Well, this is a specific case indeed of sort of more, how do you change the rules in a way that, I mean, electro-intensives are going to need to be accessing the high voltage or medium voltage to be able to electrify and using green hydrogen. And I think that certainly, again, I come back to the time that it takes, and then how do you actually get connected to the grid and what type of investments you need to make. I come back to, if you don't have certainty on being able to have access to electricity, beyond sort of the price you're going to be able to pay for, then you're going to see a delay of investments. And so it's sort of the chicken and the egg problem, where if you don't have certainty in terms of how long it's going to take you to connect, or in this case, the particular case you're talking about in Sweden, where indeed there was a change of rules. So the company that was lined up to be able to connect to the grid for their hydrogen and green steel was bumped back from as far as I understand, then you're going to have delays in terms of investments and delays in the transition. So it majorly has big impacts, and that connection time is as important as the actual building out of an infrastructure on both sides, both of the grid and of the plant.
Yeah, I think the comment here, and it's a very important question, is when is the grid problem fixed? It's a follow-up question. It's not, and it never will be. I think is the interesting point is it will likely always be a problem, and you're always going to be trying to innovate and try and solve it. So like the consequence here of electrifying everything is you've got to choose your site, you've got to choose your location, you've got to try and find ways of getting additional capacity.
But can I come back? I mean, we've been working a lot on grid modeling, and in the case of the US, and open source grid modeling, not just of the electricity grid, but other grids that you might need to. And I think it comes back to your point, Nina, around needing to be able to have a long-term planning in order to properly sort of size the grid, understanding how much of it is going to be distribution versus how much is it going to be transmission, and really the importance of sort of having more modeling, more foresight to be able to plan those investments.
Okay, yeah. Okay, a few questions on hydrogen side of things. So now, what are the climate consequences of using hydrogen instead of electricity? I see this has been upvoted a few times. So anyone like to take that as a question?
I mean, would you just repeat it again?
Yeah.
Make sure I understand.
What are the climate consequences of hydrogen use instead of electricity? I think there's a bit of a misunderstanding.
Yeah, I think, you know, there's different ways to make hydrogen. And there's been a big debate about what, you know, the colors and the gray and the brown and the blue and the green. Let's just forget about the colors for a second. How much carbon footprint do you have per kilogram of hydrogen, okay? There are technologies, if you use green energy, you have zero carbon footprint. Those obviously are going to have less impact or no impact on the environment than other technologies, which, by the way, are still excellent. I'm not trying to say green hydrogen or the zero emissions is the only way. You're going to need all kinds of hydrogen production. I don't think, you know, some of the technologies today probably need to go away, right? But if you have a low carbon footprint hydrogen, it's better than burning fossil fuels, right? So, I mean, that's really what you got. Are we making progress? or are we going backwards? In my opinion, this is not something we're going to solve overnight. We're going to have continuous improvement. I could tell you that there's not going to be enough electrolyzers built in order to solve this problem short term. You're going to need all kinds of hydrogen, but you got to rank the hydrogen based on the carbon footprint. How many kilos of carbon dioxide do you produce per kilo of hydrogen? And then compare.
So one reflection I'd like to add here is that normally it's related to the alternatives you have. I come, for example, from a country where we have a lot of forest, and we have the ocean, and we have a lot of water. So we have a lot of alternatives. And I think what's very important in these different discussions is that we have to realize that in all kinds of decisions, there are alternatives we can do. And that's why it's impossible to answer that question, because we don't obviously know. But if we have a set of resources, what we want to make sure is to use them in the most optimal way. And depending on who you are, where you're located, what is your geographic, what kind of design you have on the market, you would make different selections. And the challenge in doing the good selections is that you need a lot of knowledge to do that. And that's one of the drivers I have in my work, is trying to fit in the knowledge here, because it is so complicated, and it's getting more and more complicated. So when we talk about hydrogen, we talk about the different colors, and it has a big difference. Because if you see it as an alternative, it is definitely, I think, very important where it comes from. Otherwise, it could be a ridiculous thing. So we have to be very careful in the way we do it. So we have a lot of spectrum of choices, but in all decisions, we need to think what are the alternatives we have. Because at the end, we can't use the same for everything. So it's a lot of decisions in it. Thank you.
Yeah, you have choice. And the way that we view it at World Fund is, does it fit in the view of a regenerative world? And are you creating lock-in? And interesting, in the hydrogen one, basically you're never creating a lock-in because there's always a green alternative to make it. The question is, when does that become economical to be done? And what is the way, like, is there an alternative? Is there a better way of decarbonizing that particular sector, that particular task? So kind of a follow-up to question on that, any other technologies that can be used for decarbonizing, I think it's high temperature heat. Can we, green hydrogen is, one more time. Yes, here we are. Green hydrogen is touted as a solution for high temperatures. Are there other clean energy options needed for high temperature applications? It's an interesting question. Maybe to kind of put the first point out, it's a great solution for high temperature, but often if you can do this direct electrically, it's more efficient. The question is, if you're using hydrogen, I mean, you know this from industrial processes much better than I do, like, there are benefits to having a molecule doing things.
I mean, if a lot depends, right? I mean, if you can use electricity to, it's probably going to be, easier and more efficient. Hydrogen becomes really important when you have to move something around, or you're in a remote place where electric grid is not serving the power that you need, or you're in an industry where you're just going to burn the hydrogen directly, right? I mean, it burns clean, right? So you don't always have to take the hydrogen, turn it back into electricity to use it, right? So, or you turn it into ammonium, right? I mean, there's a variety of different ways to use hydrogen. Plus, there's a whole economy out there where we use hydrogen today that I would call high carbon hydrogen, that's used in fertilizers, that's used to make hydrogen peroxide. That hydrogen has to come from somewhere. It's not green hydrogen today. It's not zero emission hydrogen. So there's going to be a lot of consumption of hydrogen. There's a hydrogen economy that exists today for many, many years. We need to decarbonize that as well.
So wrapping up, because we've only got a few seconds left, is the electrification of sectors there's a huge opportunity, a huge demand, and if there's anything I think that we can ask for from everyone is consistency and join the conversation. So huge thanks to the panelists for joining me. Lina, Julia, Michael, thank you.